In this episode, we're going to go over torque wrenches and how to set them up, the differences between them, and some of the problems that you'll encounter while trying to use them. So here we have a standard automotive torque wrench, and you'll notice it's in foot-pounds. This is from 20 foot-pounds to 150 foot-pounds. We would never use this in a telephone office. Now, this is our standard double insulated torque wrench that most of you should have in your power kits. This is from 30 inch-pounds to 150 inch-pounds. And then this is a non-insulated torque screwdriver that goes from 10 inch-pounds to 50 inch-pounds. So this is what you're going to use for most of your applications. But when you get to a fuse panel or something that requires a lower torque setting, you're going to have to use something similar to this, because these only go to 30 inch-pounds, and most of our fuse panels that have like screw type settings are going to be around 16 inch-pounds. So this is our standard torque wrench that most of you have in your kits. Should be always stored at its lowest setting. We've looked at our documentation. We know we want to go up to 36 inch-pounds. So for this particular one, you're just going to pull this down, and then the head will rotate. It has one foot-pound increments, but only the even numbers are actually numbered. So we're starting at 30 as our lowest. So we're going to go ahead and go up to 36. You can see that we're at 36 inch-pounds by the indicator right here, lines up right on a little over 30. So then we're going to put our insulated cover on. We're going to go ahead and put our whatever size socket we need on, and we'll go up and we'll tighten it, just like it's a ratchet. Tighten it, and when it gets to the correct torque setting, which at this particular time is 36, it's going to give you a little bit of a click or pop. You just turn it past a quarter turn, and then you're done. When you're done tightening, you're going to go ahead and make sure you remember to take this back down to its lowest setting to remove pressure from the spring so it doesn't go out of cal early. Now if we need to go to something that has a lower than 30, you're going to need to use something similar to this. You could use one of these whatever type of head you need, whether it's a screw head or a socket. To set this one, it has what's called a torque setter. You're going to take it, you're going to set it in there. Let's say we want to go to 20 inch-pounds. 18, there's 20. Okay, so now we know that's at 20 inch-pounds. We go ahead and put our whatever adapter we need, and we go ahead and tighten it just like a normal screwdriver. But when it gets to 20 inch-pounds, it's going to kind of give you a little click, and you can feel that there's no tension. It just kind of like skips. And now we know it's at the right torque setting. When you're done, you go ahead and put the torque setter back in, remove tension from the spring, set it back to its lowest setting, and we're done. Now let's start to go over some of the documentation where you're going to find the torque values for whatever you're doing. Now this is TP 76300, Section K, Paragraph 4.8.6, secondary power distribution cabling to 1/4 20 connection stud on a 15800 TPS or other type fuse disconnect shall be up to number 2 American wire gauge. Power cabling to a 5/16 18 connection on a TP 158HC TPL or other type fuse disconnect shall be up to 2 American wire gauge. Torque requirements for 1/4 20 connections is 72 inch-pounds. Torque requirements for 5/16 18 thread connections is 132 inch-pounds. Now this is for posts, like on the rear of a fuse panel in a BDFV. So then we're going to go to this document, And for here, if you notice this table right here, it says silicon, bronze, or steel hardware recommended tightening torque. It says 1/4 20 is 80 inch-pounds, and 5/16 18 is 180 inch-pounds. This is for bolts. So you don't want to confuse those. This is actually for on a return bus bar. Okay, now this is for a fuse panel. This is a wood duct drawing for one of the Telec fuse panels. And if you notice here, this is for the power input side of that fuse panel. And if we look, it's going to give us our torque value. This is 36 inch-pounds. Now please note that this is a 1/4 20 post, but the torque value is less than half of that allowed in that BDFB. So if you were to torque it to that 72 inch-pounds, you're going to bust it off. Now this is the same fuse panel, but this is the output side. And for this one, it's simple. It's the same torque value, 36 inch-pounds. Now we go to this ADC PowerWorks, and this has 3 different torque values in this table. It shows 32 inch-pounds on the inputs for the A and the B, and then 832 is a 15 inch-pound max torque on these right here. And then these 632 are 12 inch-pounds, and that's for these right here and these right here. And then we go to this particular panel. This is one giving just a little more confusing. This gives you the ground terminal at 32 inch-pounds. This is 50 inch-pounds plus or minus 1 for the main inputs, A and B. And then these outputs over here are 1/4 20. They're at 32 inch-pounds. And then we go down to the screws for the GMTs. They're actually at 15 inch-pounds. And then this is a CRS 8 slot. And you'll notice on this particular one, the torque value is actually 20 inch-pounds on the back of that. And I think these are actually, these are 1/4 20 connections on this, but it's only 20 inch-pounds. If you put more than that, you're going to bust it off. And then if you look at the ground, this has a torque of 30 inch-pounds. And so it's really variable depending on the equipment. The manufacturer dictates what you're going to use. And so there's a lot of variation of where you're going to get that information in the drawing. Now this one is an MX960, and for this particular drawing, it's note 1, right on the first page. It tells us to use between 23 inch-pounds and 25 inch-pounds. So, and then this is a little excerpt from a Emerson BDFB manufacturer's documentation. So it tells us for the TLS TPS, the stud is 72 inch-pounds and the TPL is 132 inch-pounds. And that matches that earlier TP reference that we were talking about. And then this is a Lucent BDFB. So if we go to the GMT, on the screw size or nut, it's number 6, it's 10 inch-pounds. And for the fuse cartridge block or the internal return bus, we're looking at 75. The other portion of this we're not going to look at, or we wouldn't be doing. But I just want to kind of go over some of the various locations that where you can find that torque value, and to say how important it is that you actually verify that information.